Hello everyone. In this video, we'll demonstrate how to set up a project with I3C target module using MPLAB IDE and MCC Melody. To get started with I3C, you can go through the video on what is I3C and our web page on I3C peripheral of 8-bit MCUs. Also, you can refer to MCC Melody technical reference to learn more about MCC Melody. All the links are mentioned in the description. We have opened MPLAB IDE. Now let's create a project using PIC 18F16Q20. Select the device. Choose the compiler. Add the project name. And click on Finish. The IDE has a built-in code configurator MCC, which can be opened by clicking on this icon. MCC consists of various drivers that help you to easily configure the peripherals and generates APIs that can be used in your application code. Select MCC Melody and click on Finish. There you go. Open Content Manager tool to select the latest versions of driver library. For using the I3C target DMA driver, make sure the DMA plib version is 1.1.0 or above. Alright, first let us configure the system clock. Go to Clock Control and select 64 MHz internal clock. To add I3C driver, go to Device Resources, expand I3C under Drivers, and add I3C target DMA driver. As Q20 supports only target functionality, this is a driver for the I3C target module. Also, to support high-speed data transfers in I3C, MCC currently has a DMA-based I3C driver. In the future, we would support non-DMA-based drivers as well. This tooltip directs you to the online API reference page, which will help you to quick start on I3C driver and illustrates how to use I3C target APIs. Now to configure the I3C module, open I3C target DMA driver. It supports all the settings related to generic protocol features. First, we need to choose the peripheral selector. Q20 has two I3C peripheral instances. I will select I3C1. As it's a DMA-based driver, next up is the selection of DMA channels for transmit and receive operation. This would not be required in non-DMA-based driver. Let's select DMA1 for transmit and DMA2 for receive operation. Note that the selected channels will not be available for other application requirements. Plus, all DMA channel settings are automatically controlled by I3C target driver and the user cannot change these settings. The configurations for I3C protocol and the target device are available under bus configuration, target configuration, and target speed settings. You can configure them based on the application requirements. Next, the configurations related to hot join, IBI, private read-write transactions can be configured under transaction settings. That's all in I3C target driver. Now, to configure the settings specific to the I3C hardware peripheral, open I3C plib from the builder view. The plib GUI includes clock selection for I3C peripheral, I3C pins buffer selection, and the various system level and module level interrupt settings. Configure them based on your application needs. As you can see, all the configurations that we had in I3C target driver are also available in I3C plib, but as read-only. Next up, we'll see the I3C pin configuration. The I3C module uses dedicated SCL and SDA pads, and these pin locations are not remappable through PPS. One of the highlight features is that the I3C SCL and SDA pins on Q20 operate in a different voltage domain powered by the MVIO, that is, multi-voltage I/O pins. Go to Configuration Bits, select the high-frequency internal oscillator as reset oscillator. Go to Configuration Byte 7 and select Operating Voltage Range of VDDIO based on the voltage applied to VDDIO pin. Ensure that this voltage range matches with the I3C input buffer selection. For example, if the input buffer for I3C pins are selected as FST, then the corresponding VDDIO pin must be in standard operating range. After configuring I3C target with DMA driver, click the Generate button to generate the source code. As you can see, I3C1.c, I3C1.h, source and header files of DMA1, DMA2 are generated. You can find the APIs to use in the application code from I3C1.h file. Now, let's open the API reference page using this tooltip. This page has a couple of use cases on how to use these APIs. Let's take the example of private write transaction and see how it can be implemented in the application code. Here is a code snippet. Copy it to your main.c file. The application code for private write transaction using APIs of I3C target driver is ready. The application code must maintain the buffer for holding the received data from private write transaction. Make sure to keep this buffer size higher than the expected size of data received from the controller. There are few code examples available on Discover portal using the I3C target driver for PIC 18F16Q20. These are also released in GitHub. In addition to this, you can go through the example demo video using I3C target DMA driver. Also, refer to the product page of PIC 18F16Q20 for more information about this device. The links to all resources are mentioned in the description. Thanks for watching.